Okay, we have Sam Bellen, and you have so many weird things in the name of your talk that I don't even want to try to say it, but you'll probably be able to explain everything really clearly to every one of us.
Hopefully by the
So
end of this
welcome,
talk, yeah.
Sam, and yeah,
Hey,
can you maybe put a little bit volume on your mic? It's a little bit silent before we start.
let's see, how's this? Is this better?
Yeah, that's at least totally good. Okay,
Okay,
so
perfect.
go ahead.
So hopefully by the end of this talk, all the words in this sentence, in this title will make sense. But because the theme of the conference was something like connecting digital with physical, I thought it would be a good opportunity to talk about the Web Authentication API, also known as WebAuthN, which is basically a means of protecting digital identities with physical authenticator devices. Now, the WebAuthN is a browser API, so it's not 100% related to the Apidays crowd, which deal with backend APIs. But because we're dealing with a paradigm shift in our authentication flows, it does make sense to cover this as well on this conference, because we have to do things a little bit different on the back end as well when using the Web Authentication API to authenticate users on the web. Let me quickly introduce myself. My name is Sam Bellen. I'm a developer advocate engineer at Auth0. If you don't know Auth0, we're an identity as a service company, which means that we try to make it as easy as possible for anybody to implement a secure authentication flow, so you can focus on building your actual applications. I'm also a Google developer expert, and you can find me on the internet as @SamBego. If you've got any Auth0 questions, we have a sponsor booth in the partner village, and some of my colleagues will be there to answer any questions you might have, so pop on by there. And these slides are available at webauthn.sambego.tech. So if you'd like to follow along on your own device now or after my talk, you will find the slides here. So what will I be talking about today? I'm going to talk about WebAuth what is WebAuthn, why you should use WebAuthn, and also how does this WebAuthn application API actually work. So let's get started with the what. WebAuthn, the Web Authentication API, is a browser API specified by the W3C standard, but it's commonly known as WebAuthn. So if you want to Google for some more information, WebAuthn might give you some more results than the full name Web Authentication API. It's a key-based authentication API, which means that it uses a private and public key pair to authenticate. We might be able to get rid of passwords just because we are able to use that private and public key pair to authenticate users on our applications. It also requires a user interaction while dealing with this authentication flow while using this public and private key pair. And it uses hardware authenticator devices. So it's not just a software implementation, it relies on some hardware authenticator devices to store and create those public and private key pairs and to use the private key to do certain actions, which we'll see a bit later in this talk. So if you don't know what these hardware authenticated devices are, here are a few I have on my desk at the moment. They go from very fancy hardware authenticators with a screen to very simple USB-C, USB-A, and whatever you can imagine in between. And you can connect them to your devices with a whole range of mechanisms, the more simple one being USB, USB-A, or USB-C, depending on which kind of device you have. We also have Lightning ones for iOS devices, Bluetooth Low Energy, and NFC for example, Android devices. So they don't only work on your laptops, they should work on any device that has a USB port or Bluetooth or Lightning or NFC capabilities. And usually, if I would be standing in front of you in real life, I would ask who has one. But since I cannot see any hands go up, I'm just going to assume some of you have one of these and some of you don't. The good news is that most modern devices have a built-in authenticator device inside of them. So most modern laptops, most modern cell phones and tablets have a specialized chip inside of them that takes over the role of these external authenticator devices. So even if you don't have one of those external, we call them roaming authenticator devices, the chances are very big that your laptop or your phone or your tablet that you're using at the moment also has one of them built in. That was a real short, what is WebAuthn? But why should we use WebAuthn? It sounds way more complicated than just using the regular way of authenticating that we're used to on the web. So if we look at a normal login box that we see all over the internet these days, when you want to log in, you type in your username and your password and you click login. But since I'm in front of a bunch of people, I'm a bit nervous, so I'm not that good at typing, so I mistype my password. I try again. Maybe I'm a bit nervous, maybe I'm not good at typing, but third time is the charm, right? So I try it again, log in. Seems that I'm not good at typing, or I might have forgotten my password, so I'm going to try to reset my password. And when I try to do this, you get a message like, your new password can't be the same as your old password. Turns out that I did remember my password, I was just not that good at typing. It's very annoying. Passwords can be very annoying for users to use. It's not a very great user experience. Also, passwords can be insecure because they're usually the weakest link in our authentication flow. If they get compromised, or if users don't use a good password, they might be brute forced. So they're always a weak link in our authentication process. And passwords can be stolen. You hear about data breaches all of the time. Luckily, not all of them include passwords. And luckily, if they include passwords, they're not always stored as plain text, but sometimes they are. So again, passwords are always a weaker link in our authentication process. So if we could get rid of passwords and use a public and private key mechanism instead, that would be a big plus in my book. So if we have the same example again, instead of a username and password input, we only have a user input. So I type in my username, I click on login, and my browser now asks me to touch my Touch ID because I am working from a MacBook Pro, which has Touch ID. And once I touch my Touch ID, I'm going to prove to my browser that it's my device, that it's me, and I can authenticate successfully using my private key stored securely on my MacBook Pro, and by verifying that it's me using my Touch ID. How this works, we'll see in a second, but the thing we should take away from this example is, instead of typing a password and sending that to the backend to be stored and validated each time you authenticate, we're going to use a private key to sign a challenge, and we're going to use a public key to validate a challenge. Very cool. No more passwords, no more bad user experience, no more weak link, or not at least not a password weak link in our authentication process. That's all cool. So how does this WebAuthN actually work? Well, the first thing we need to do is the same as with when you work with a username and password credential combination. You have to create a new set of credentials. And what we're going to do is we're going to type in a username on the website, on the application, whatever you're building. We're going to send that to the backend. We're going to store this in a database. And the backend, your API, is going to generate a challenge. This is a randomly generated array buffer. We do this on the backend, so we have a cryptographically secure random number generator. And we send that challenge, an array buffer with random data, back to the browser, which will relay it to our authenticator device. And our authenticator device is going to do something with that challenge. But first, WebAuthN relies on a user interaction. Before you can actually use WebAuthN to generate a new set of credentials or to authenticate in the next step, the user has to do something. I had to touch my Touch ID in the previous demonstration. If you have some of the external authenticated devices, you might have to touch your YubiKey or your Titan key. If you have Windows Hello or an iPhone with facial recognition, you might have to do this. But it will always verify that there's a user present before doing anything with your authenticator device. So once I touch it, it's going to sign that challenge with a private key that is being generated. It's going to send back that signed challenge together with the public key, which matches or which is linked to the private key. And it's also going to send back the private key ID, so we can use that private key the next time we want to authenticate. And we can forward this to our backend, where we can safely store this in our database, because it's all public data. A public key is public data. A private key ID is just an identifier of a private key. It's not the actual private key itself, which stays securely on our authenticator device. So once the user is registered, we can authenticate the user. And again, we're going to send the username to our backend, and we're going to check in our database, do we have a private key ID stored for this user? If so, we're going to send this back to the browser together with a new challenge, a new random number in a array buffer. And we send this, the browser will forward this to our authenticator device. Again, we have some user interaction, and it's going to use the same private key that it did in the previous step to sign that challenge, and send that signed challenge together with the public key, if necessary, through the browser to your backend, where you can then validate that signed challenge based on the public key information that you've stored from the first step when we registered a new set of credentials for this user. So that's the basic overview of how this works, the back and forth between a browser, an API or backend, and the authenticator device. But how does this work in code? Well, the first thing we need to do, again, is create some credentials. And then we So it's a browser API, it's JavaScript, so we have to run navigator.credentials.create, which accepts a bit of a configuration. The first thing we want to specify is the challenge, that array buffer with the random data. Next up, some information about the relaying party. That's your authorization server or your website or application that you're currently working with. Some information about the user, maybe a name or a display name. And then a set of public key credential parameters, which means algorithms that you know how to use with. If we look up the algorithm -7 on the COSE algorithms list, we can see that it boils down to ES256. So you can specify a bunch of algorithms that you know how to deal with, and your authenticated device will pick on the first one it knows how to work with itself from this list of algorithms. A timeout, how much time the user has to complete the whole process of touching the Touch ID or whatever it needs to do in milliseconds. You can exclude certain credentials if you want to revoke certain credentials for certain reasons. You can pass along their ID in this exclude credentials array. And lastly, some more information about which kind of authenticated devices you'd like to accept on your application. Platform are the built-in ones. Cross-platform or roaming are only external ones. If you leave this blank, both of them will be accepted. The same thing, do you only want to accept authenticated devices that have user verification, things like Touch ID or Face ID, opposed to something that only verifies that there's a user present, but doesn't really verify the identity of a user, which is me touching my YubiKey, for example. It only looks for a touch, but it doesn't really check my fingerprint, while my Touch ID might be able to do that. And require resident key, which we'll see in the end of this talk. Lastly, attestation direct. We will not go into many details here because, well, we simply don't have the time for that. But that's all you need to do. You specify all of the configuration you need to do, and the browser will take care of sending that configuration to your authenticator device, and that authenticator device will then sign the challenge with the newly created public and private key pair. And next time the user comes back and wants to authenticate, instead of calling navigator.credentials.create, we .credentials.get, again with a little configuration, a new challenge, a new array buffer with random data, and a list of allowed credentials. And in this list, in this array, you can pass along all of the credentials that you've created for a user and stored in your backend previously. So you will pass along a credential object for each of the credentials that you have stored in your database linked to a user, where the ID will be the private key ID of the private key stored on the authenticator devices. And you can also set user verification to preferred if you prefer that they use an authenticated device that verifies a user. But that's about it. Once you set this configuration, it will again be sent to the authenticated device, which will sign that challenge using the private key that it finds in that list that you specified, and send it all back to your backend so you can validate the signed challenge based on the public key data that you have stored in your backend. But how does this work on a backend? It's an API conf. We have to talk a little bit about backend stuff as well. So the first thing, again, when we create a new credential, what we get back from that navigator.credentials.create method is the ID or the raw ID from the private key, the type, it's a public key. So we also get a public key back, and then a response with some client data JSON and an attestation object. The client data JSON object is a JSON string in the form of an array buffer. So you first need to parse that array buffer and convert it into a JSON, into a string, and then into JSON. But once you do that, you can see that it comes from a WebAuthN.create method that in the original challenge was the one that's returned, and the origin is hopefully the same origin that you were working on. The attestation object is a CBOR encoded array buffer. And CBOR is concise binary object representation. So if you want to get to the contents of that attestation object, you'll have to decode that CBOR array buffer. And once you do so, you might get something that looks like this, which contains a bunch of data. The most important part is the auth data, which will contain the attestation credential data, which is our credential public key information, which we'll save in our database so we can verify signatures every time the user gets back. So what we need to do when we create a new credential for a user is validate the returned authenticator data. Is there an ID? Is an ID of a public key or a private key? Sorry, if there's none, something went wrong. Next up, we validate that the challenge is the original challenge that we've sent to the authenticator device, and that the origin is the website or the application that we're currently working on. Next up, we want to check if the user is verified, if that's something we want. If we only want to, if you also want to allow users that have not verified their identity, that's fine. That's up to your application logic. And lastly, you save that credential ID, which is the private key ID together with the public key data in your database. And when verifying an existing credential, you get back something like this from the navigator.credentials.get, the signature, the user handle, again, some client data, JSON, and an authenticator data object. And what we do in the backend is validate that user. Is it for the user that we expect it to be? Is the challenge the one that we originally sent? And is the origin what we expect it to be as well? And validate the return signature based on the public key data that we have stored for our user in our database. Last up, I still have a few minutes, resident credentials. You can use resident credentials when you set the require resident key to true when registering a new credential. And what this means is that it's not only going to create a new public and private key pair for your user, it's also going to store some user information on your authenticator device. And if we try to do this as a demo, I'm going to WebAuthN.me, which is a website that we've created where you can play around with the all of the configuration of WebAuthN. And we try this with Apidays as a user and Apidays as a display name as well. And we enable require resident keys and press register. I'm going to use my YubiKey attached to my computer. It's pin code protected as a second factor. Touch it again. But now I've created a new set of credentials for this website, WebAuthN.me, using my YubiKey. This is a returned data. But if we now try to authenticate, instead of passing along a list of allowed credentials, we're just going to ask the browser, do you have some, or does the authenticated device have some credentials for this website stored? If so, we're going to select the same key again, touch it, open it up and touch it again. And when we do this, you see I have a bunch of credentials stored. Maybe I should make this give us a bit more time. But if we do it again, you can see that the Apidays credentials are now available in the list of credentials I have saved for this website, WebAuthN.me, together with some previously registered credentials. So if I click on it and authenticate, we get a valid authentication response as well. So resident keys allow you to not only create a private and public key pair, but also store some information of the user on that authenticator device. So they don't even have to type in their username if they don't want to. The website I just used is WebAuthN.me/debugger. So what are the benefits of WebAuthN? They're private and public key-based authentication. It's a bit more secure, and you don't have to deal with passwords or store these passwords in your database. It's phishing resistant because it's always based on the origin. If I register a set of credentials for WebAuthN.me, they will not be available for any other origin out there, any other website. You only store public data in your database. You only store the public key information, a username, and the ID of a private key, but not the private key itself, which stays securely on the authenticator device. You get fine-grained control of which kind of credentials to allow. Only allow internal, external roaming ones, maybe only allow ones that have user verification and so forth. It's a better user experience because the user doesn't have to use a password manager or remember a password. And lastly, no more passwords, which is something that makes me very, very happy. So still some issues to be solved because it's quite newish. It's been around for quite a bit, but still new to most people. The first thing is user credential management. In most cases, you cannot manage the credentials stored on the authenticator devices. You might be able to remove them all, but you will not be able to edit certain ones. Chrome has this menu, but I have never been able to get it to work. And if you use a YubiKey, you can reset the YubiKey, which means remove all of these stored credentials, but you cannot just choose a few to remove or to edit. Also, cross-device credentials, because they're stored on the authenticated device, if your authenticated device doesn't work with other devices, because they might have a USB-A and you only have a USB-C version, for example, you will not be able to use them. So you'll have to create a new set of credentials for each device that you don't know how to work with your current authenticator device. which also means that if you lose or your authenticated device gets stolen, you need to be able to have a mechanism to recover your account because you will not have access to that authenticated device. This might be a password, this could be something else, but there should always be a backup way to recover your account. WebAuthN might replace passwords. It will not replace token-based authentication or authorization, things like OAuth or OpenID Connect, and it will not replace identity providers like Auth0, just because it only replaces that password part in the authentication flow. It's a W3C recommendation, which means that it works in all major browsers. And you can use this already on most of the bigger websites out there, which means any website that uses Auth0, also Google, GitHub, and a lot of the bigger ones out there. If you use Auth0, you can configure them as a second factor with the multi-factor authentication screen in your dashboard, either for external ones or the internal ones, which use biometrics like Face ID or Touch ID. Or you could use them as an identifier first plus biometric flow, which means that you only enter your username, and if there is a biometric authenticator available, the Auth0 login screen will ask you to use that instead of a password. And if it's not available, it will still fall back to a password. I think that's all I've got, but I'm out of time as well. So let's summarize. WebAuthN is really awesome. It lets you stop using passwords, and it should be a bit more secure. If you like to play around with that debugger I showed you before, WebAuthN.me, specification or blog is full with good stuff. And the slides are available at webauthn.somebeagle.tech. That's it.
Great. So I can already see quite a lot of possible use cases for that in some of the projects that we are working on. But Med here has a question that how does WebAuthn work with GNAP, Grant Negotiation and Authorization Protocol? Does it even?
I don't think it's related to this because, like I said at the end of this talk, it only replaces that password part. You're still going to do everything after you've checked your password or username password combination, or your username and their WebAuthn credentials is still going to remain the same. So whatever you do behind after that part of the authentication flow is unchanged.
Yeah, and I guess it also applies to, like, okay, you might have whatever device, as you said, as the authenticator, but it still needs to kind of talk web in a way.
It's a web browser API, so it only works through a web browser. Yep. If you have a mobile app, for example, they have other APIs that do more or less the same thing, which is let you use Touch ID or Face ID. But this is a web browser API.
Yeah, exactly. Really important to keep the scope. Hey, thank you, Sam. Wonderful as always.